The next thing we're going to visit about are what makes an equation a conditional equation, or an identity type of an equation, or an equation that is a contradiction. So far, we've seen equations that have exactly one solution. These are called conditional equations. A conditional equation is true for some values of the variable and false for other values. For example, on the last on example 2, we got that the value for t was 110. That makes the equation true. For any other value for t, it makes the equation false. That's the condition. An equation that's true for all values of the variable is called an identity, and an equation that is false for all values of the variable, there is no solution, is called a contradiction. Okay? So we're going to look at those different types in example 4. This asks us to identify each equation as a conditional equation, a contradiction, or an identity. Then give the solution set. So for number 40, the first thing we are going to do is clear the grouping symbols on the left-hand side of the equation. 4 times 3 is 12. 4 times a negative 5n is negative 20n. And then bring down the plus 1. To go ahead and combine on the left-hand side, we're going to have a negative 20n plus 12 and 1 is 13. On the right-hand side here, when we combine the negative 4n with the like term of negative 16n, we have negative 20n minus 8. Okay, let's go ahead and just bring that down to the next line. Negative 20n minus 8. Now going to do our algebra moves to get constants on one side and variables on the other. We're going to go ahead and add 20n to both sides. And look what happened here. When we added 20n to both sides, our variable terms fell out on each side, just leaving us with the statement 13 is equal to negative 8. Now when that happens and your variables fall out and you're left with a statement that is false. That is false. That means we're going to have a contradiction. And that means we have no solution. Therefore, what do you suppose that solution set would look like? Well, there's nothing to go in it. So our solution set is what we call the empty set, and that is the symbol for an empty set. It consists of no elements because there is no solution. Another way that you can write empty set is by a circle with a slash through it. That means nothing exists in our set. These two symbols mean empty set. That is why I would like to caution you against writing your zeros. Some people write a 0 with a slash through it like this. Do you mean the number 0 here, or do you mean nothing? You know, nothing, no solution. So you better be careful about that. On number 42, again, let's simplify each side of the equation. Oh, I don't know where I got the x. This is just going to be a negative 5 plus 3x on the left-hand side. It's pretty great that I messed that up, didn't I? Okay, here we're going to run the 3 through. So we have 3x minus 3. Bring down the negative 2. So we have negative 5 plus 3x equals 3x minus 5. You may notice right here that the left-hand side of the equation is exactly the same as the right-hand side of the equation. If you didn't notice that and went to do your algebra moves of subtracting 3x from both sides, once again, just like on the last example, once again the variable parts are going to fall out, but this time we are left with negative 5 equals negative 5. This is a true statement, and that makes all the difference in the world. Since that is a true statement, this is where we have an identity. That's what type of an equation this is, an identity. And the solution set consists of all real numbers. How are we going to put everything inside of this solution set? Well, I don't want to list out all the numbers in the whole entire world. I don't know about you. But one thing we can do is we can write it in what we call set builder notation. Our answer is going to be the set of all values for x because that was our variable. And I wrote a vertical bar here, and anytime you see a vertical bar inside this set builder notation, you read that as such that x is an element of the real numbers. Fancy stuff going on here. This is set builder notation, and the set of all values of x such that x is an element of. That is a little bit janky. It's actually a this with a that through it. That's a little bit better symbol for an element of the set of real numbers. It's just a capital R, but with two bars here. The set of all real numbers. That's a fancy pants way to write the whole shebang. That's one way to write all real numbers. If we wanted to look at our solution set as interval notation, you could also say anything on our real number line for x from negative infinity to positive infinity. I believe probably you will see or be asked to use this of some sort. They might just say all reals, something along those lines, or you might see it like that. Okay. Our next example is number 44. Once again, I'm going to clear out these fractions by multiplying everything through by the least common denominator of all the denominators, and I think a 6 is going to do it for us. So I'm going to come along here and squeeze in multiplying each of these terms by a 6. Remember, we can do that because of our multiplication property of equality and our distributive property. Now comes the fun part where we get to start wiping out those common factors. 3 for this term will go into 3 one time. 3 will go into 6 2 times. So we're left with 2 times 2y, which is 4y. Okay, here nothing to reduce, so 6 times 5 is 30. Here we can reduce the 6's, leaving us with just 1y. Minus 4 times 6 is 24. Okay, let's do our algebra moves to solve. We're going to subtract y from both sides. To move the constants to the left-hand, those are variables to the left-hand side. So we are going to add 30 to both sides to move our constants to the right-hand side. Once we do this, we are left with our equation 3y equals negative 24 and a positive 30 combined to give us a positive 6. Divide both sides by 3. So our solution is y equals 2. You know, we've seen things like this before. Now we know what to call it. This is a conditional. When you get only one answer like this, it's a conditional type of an equation, and the solution set just consists of the element or elements, perhaps, that satisfy that equation.